Hello, today we're going to talk about analyzing graphs. Alright, the first thing we're going to do is graph a function by using a table. So, use f of x equals 3x plus 2. So, using a table, and I'm going to do this an expanded way out, and I'm going to use the numbers 0, 1, 2, and 3. Alright, so ease a little bit further down. There we go. So to graph a function with a table, this is the way to do it. You don't have to do this middle section. I'm just doing it to help. So I plug in 0. So I say f of 0 equals 3 times 0 plus 2. Because whatever I put in for my x here, I put in right here. So f of 0 equals 2. So my first point is 0, 2. Now I'm going to do my second one. So what if f of 1 equals 3 times 1 plus 2? 3 plus 2, which is 5. So it gives me the point 1, 5. Now we'll do 2. So f of 2 equals 3 times 2 plus 2, which is 6 plus 2, which is 8. So I get 8, so my point is 2, 8. And my last one's going to be 3, 11. I'm not going to plug that in, but I can see every time I add 1 to my x, I add 3 to my y. So 2 plus 3 is 5, 5 plus 3 is 8, 8 plus 3 is 11. So I know my last point. Now I need to graph this. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5. I don't even need to do that. Let's just make this a little bigger. 2, 3. And there we go. So my first point is at 0, 2. My next point is at 1, 5. My next point is at 2, 8. And my last point is at 3, 11. Then I just draw a line to connect them. And that is how you graph a linear function using a table. You can make it simpler if you want, however you want to do it. So, all right, a couple terms you need to know are independent variable. So the horizontal axis is the input, or horizontal. That's the input or your x. The vertical is your output. It's called the dependent variable. So independent variable, dependent variable. All right, so now these are just, I like to call them story graphs. So it's looking at a graph and being able to tell a story about it, what's happening in the graph. So we got one here. I didn't actually draw it on there for some strange reason. All right, distance, time, and this one's money and time. We're gonna make a story about it. Not really a story. So this is just showing how far he's going over a certain amount of time. So he starts off going a good speed, but then what happens at that? So from here to here, he starts, or he's moving slow, or he's moving at a constant thing. So what does it mean when that line automatically stops and starts going a lot quicker? The rate changes faster, the slope is faster. So if he's changing his distance much faster, that means he sped up. So he was going at a constant pace. So say you're walking, then all of a sudden you look at your watch and you realize you don't have as much time as you had. So you start sprinting. That's what this graph shows. You start off slow, and then you sprint to where you need to go because you're covering more distance over a shorter time frame. So say from here to here is 5 seconds, and say from here all the way over to here is 3 minutes. You covered much more distance in that 5 seconds than you did in that first 3 minutes. It's telling a story. So here we go here. distance over time. So what's happening here? Well, he's starting off fast, so he might be running because he's covering a large amount of distance over a short period of time. So say this is 2 minutes. All right, then from here to here is 10 minutes. So what happens to this person when that line is flat? Are they covering any distance anymore? No. So you can say they started fast, then they just stopped and just stayed where they were at. Right? Started fast, stopped, and just stayed. Right? It's all about reading the graph correctly because they're not covering any distance anymore. So they might have sprinted, pulled their hamstring, and now they're laying on the ground this entire time stretching. Money and time. All right? So what's happening to this money as time is going on? Well, it's losing it. So you could say it's someone, well, I don't know if they have them any. Well, yeah, they do at Monkey Joe's because I destroyed Crossing Road. The amount of money you have. So if you're at an arcade playing a game or like a claw machine, you have $20 to start, and then you continue to lose money over time. That means you're playing that game consistently, and you eventually run out of money when you get down there. So that's what it is. You're basically just paying someone that entire time that the money's running out. All right, here are some more examples of telling stories. So this is distance over time. So what's happening here? So this person starts fast. Now what did we talk about the last time? So here they're fast. Now here, if they're not moving any distance over a given amount of time, they've stopped. But then they start up again this time and they go fast. So start fast, stopped, and then finish fast. All right, it's all about being able to read it and knowing what you're actually looking for. Your independent and dependent variables. So your independent is your time, your dependent is your distance here. All right, distance over time. So this one, you start far away, and then you sprint, so then you run. Let's say this is your house right here. So this line will represent where your house is. So you start far away from your house, then you run to house, then you run back. Let's say you're at the store, and then you run back home. Or you could say this is, if you guys have ever played a sport like basketball or any sport, you start on a baseline, you sprint to the other baseline, you sprint back to the original baseline, and you sprint back to the other one. We used to have to do, they're called, 17s, or the nasty nines. We have to run the whole court 9 times in like a minute. 1, 2, and that's all it is. You start somewhere away, you run somewhere, you run back to that original spot, and then you run there. So it's like doing sprints in basketball, basically. All right, so this one right here. All right, what can this represent? All right, well, it can represent jumping. All right, but not jumping off the ground, jumping on a trampoline or jumping on a table. All right, something like that. Because it's not on the ground, because if it's on the ground, it would be all the way down here, a distance of 0. So it's just jumping. Jumping up, coming down, jumping up, coming down, jumping up, and so on and so forth. There you go. The last one, real quick, I'm gonna show you, is just climbing. So if you were climbing a mountain or something, it would just look like this. Just climbed a little bit, stopped, climbed, stopped, climbed. Even looks like a mountain. So there you go. and that would be height over time. But you see the difference between this one and this one is on that one, you're actually off the ground already. This one, you started on the ground and started climbing up. All right, analyzing graphs can be difficult. If you take your time and really look it over, you should be all right. And making sure that you know what your independent and dependent variables are, it helps out a lot. Hope this helped. This was Analyzing Graphs. Good luck.